Welcome back, fellow explorers, to Project Opono. In part 1 of this episode, we saw how the formation of the Hanakusa Plains impacted the native lifeforms of Matsi. In this part, we will see how the formation of the Apovlitoan grasslands will impact the native lifeforms of Apovlitos. As explained in part 1 of this episode, the planet is going through rapid changes as a result of the smoke, ash, and aerosols in its atmosphere as a result of the movement of the continents. This has begun to dry out the planet, thus resulting in the inland forests of the past starting to dwindle, leading to the formation of vast open plains. The parvicormo of the plains will have to adapt quickly to this drier habitat, or face extinction in the continental interior. Their thick leaves lose water through transpiration, with the water evaporating through their stomata constantly throughout the day. Coupled with their above-ground meristem, this may result in the parvicormo dying either from water loss or having their meristems damaged by herbivores. So the inland parvicormo may evolve to circumvent these issues by keeping their main body and meristem below the soil. Their large leaves may also thin out as they grow longer to avoid excessive transpiration, but still have a sizable photosynthetic surface area to stay alive. We will call these tall grass-like plants the altafillo. Their leaves can grow up to 1 foot tall. Other parvicormo in the plains may evolve some similar adaptations to those of the Arbostophyta of Matsi. A thicker stem, more robust roots, and larger leaves will allow them to suck in and retain water, grow larger than the grass around them, and take in more light than their competition. These plants will be some of the largest plants remaining within the vast interior of the plains, making them more successful than even the trees of the ancient forests. We will call these robust bushes the Paleodophyta. They grow up to 2.5 feet tall and will be some of the most prolific large plants in the plains. As the altafillo and Paleodophyta begin to take over the continental interior, herbivores will flock in droves to colonize this new habitat. The contrapods of the ancient forests may quickly find a home in this habitat, seeing as they already eat small ground vegetation within the forests. Having been ousted from megafaunal status by the macroproso, perhaps one contrapod lineage evolves yet again into megafauna, evolving into lumbering grazers to strip the altafillo and Paleodophyta to the ground, like giant living lawnmowers. However, as their size and weight increase, the rings of cartilage that make up their skeleton may not be able to support their weight anymore, so perhaps the cartilage of these creatures' skeletons evolves to ossify into true bone, giving them massive amounts of support while also allowing them to be flexible. Their tentacles may change as well, with the bottom 2 tentacles becoming vestigial as their top 2 tentacles evolve into the primary feeding limbs, growing longer and more muscular to pluck plants out of the ground and bring them into the mouth. We will call these megafaunal contrapods the variopods. They grow up to 7 meters long and live for up to 36 years. However, the macroproso themselves may find a home in the open plains, adapting to feed in the gallery forests that form around the inland rivers and lakes of Apovlitos, where remnants of the ancient forests still thrive. However, these creatures are now so massive that their 2 legs may not be able to support their entire body on their own anymore. However, these creatures possess a tail at the back of their body. Perhaps in this context, it could be useful. The tails of these creatures are already super strong and muscular, so perhaps they could evolve into a sort of 3rd leg that they can use to support their massive bodies, along with their 2 other legs. Their tails will be similar to those of kangaroos on Earth, being able to be leaned on when feeding to support their massive body and weight. Their trunks may also lengthen significantly to be able to reach the tops of the tallest trees, making these creatures the largest herbivores yet seen on Opono. As this happens, their eye stalks migrate to the sides of their heads to be able to see around their massive trunks and find their food better than their ancestors could. In the case of reproduction, the mothers of this clade will be extremely strict on their young, picking them up with her trunk if they are misbehaving, before setting them down somewhere else, likely under her body. However, when the young are born, they won't have the capabilities of feeding on plant matter like their parents. So the mother will give her children a special form of food in order to get the guts of her young filled with the bacteria. They need to be able to digest plant matter. On Earth, koala mothers produce a special form of digested matter called pap. This pap is filled with all the beneficial bacteria. Their children need to be able to digest the eucalyptus leaves they feed on. So perhaps these macroproso do something similar, producing a specialized poop filled with millions of beneficial bacteria that their young then ingest. To get the bacteria they need into their digestive tracts, the young will feed on this special poop until they're able to eat leaves on their own, after which their mother will stop producing it altogether. Interestingly, these creatures are very social, always migrating together in herds of up to 150 adults, with the children of the herd always placed near the center to stay protected from predators. We will call these bizarre giants the caudipod. They grow up to 25 meters tall and live for up to 65 years. With the abundance of megafauna in the plains, it is inevitable that their bodies will be left within the grass, being a prime food source for scavengers. Perhaps a clade of Cocolophoros adapts to life in the plains. These creatures, being as adaptable as they are, may quickly monopolize the niche of scavengers. These creatures' bodies may morph into a strange appearance, with their eyes positioned on stalks to see what's in front of them, a tail for stability, and an elongated, flexible spine. However, their most striking adaptation is with their legs. These creatures' legs have become extremely powerful and flexible. The reason why is that these creatures have evolved to hop instead of walk. On Earth, the legs of rabbits and frogs are extremely muscular and powerful to allow them to hop from place to place instead of walk. So these Cocolophoros have convergently evolved extremely muscular, powerful, and flexible legs to be able to hop from carcass to feed. To do so, their feet have become extremely long, to be able to have as much area as possible for them to leap off from when they hop off the ground. We will call these strange hopping scavengers the Prizonology. They grow up to 1.5 feet tall and live for up to 15 years. Perhaps a relative of the Prizonology instead goes for a niche of speedy herbivore instead of a scavenger, adapting to feed on the abundant Altophylo. Their powerful legs, elongated flexible spine, and long tails may already make them pre-adapted for the life of a cursorial runner, and so these traits may be exaggerated to their maximum potential. Their tails may lengthen to half of their entire body length, and their spines may be hyper-flexible, at some points even allowing their tails to bend between their legs. Their legs may themselves lengthen dramatically to give them the longest stride length possible for a bipedal animal. The last adaptations these creatures may make is evolving hooves at the tips of their singular toe. Hooves on Earth offer a great deal of benefits to a cursorial animal. They provide a wide, flat surface area for them to push off of while running, and add a great deal to their overall stride length. The culmination of all of these traits in these creatures may lead to them being considered cursorial, allowing these creatures to run extremely fast, being one of the fastest animals on the planet. We will call these speedy creatures the Lophori. They grow up to 3 meters long and live for up to 29 years. With the abundance of prey in the plains, it is inevitable that predators will evolve to feed on them. Perhaps a population of Grigoroavgo evolves to hunt the swift Lophori that feed amongst the large herbivores. However, to do so, they may need to make some physiological changes to their body plan. A longer tail raised above their heads will allow them to stay stable while running at extreme speeds, chasing after their prey with deadly accuracy. These creatures may also evolve a crest on their heads used for many purposes. Its main purpose will be to allow these creatures to stay aerodynamic while running, cutting through the air like a knife, similarly to a fish's dorsal fin. However, it serves another purpose, attracting a mate. The males with the largest crests get more attention from females, thus resulting in a feedback loop that serves for larger and larger crests. This is yet another instance of sexual dimorphism, where the males and females of a species are completely different from one another, but in this instance, Both males and females have crests, but the males have larger brightly colored crests, each with their own unique pattern of blues, purples, and pinks. This is called sexual selection, where females of a sexually dimorphic species typically mate with the males with the most extreme ornamentation. This is because, despite the males having such an obvious handicap, surviving to adulthood shows an indicator of his fitness, and thus he is most likely to get a mate. But with such extreme ornamentation, how are they not spotted by their prey? You see, all herbivores on Apovlitos exhibit dichromacy, meaning that they only see two colors, red and green. This means that most herbivores can only see the colors of their food, mainly yellow and orange. However, most predators on Opono exhibit trichromacy, meaning that they can see blue, red, and green light. This means that to them, their crests are brightly colored, but to their prey, they are yellow and orange, meaning the Grigoroavgo are safe from being spotted, keeping themselves camouflaged. The last adaptations these creatures may make is in their legs. These creatures' legs are positioned at the sides of their body. This isn't that great for a fast-paced pursuit hunter, so the legs of these plains-dwelling Grigoroavgo may be positioned under the body, giving them an erect limb posture, allowing them to keep pace with their prey and catch up with them. We will call these speedy predators the Onhuaitso. They grow up to 2.5 meters long and live for up to 25 years. Other predators in the plains may adapt to feed on the megafauna, lumbering across the land, feeding on the abundant plants. The Leptosoma may be the perfect candidates for this, seeing as they already hunt forest megafauna. Similarly to the variopods, their cartilage ring skeleton may ossify into real bone, allowing them to grow in size to hunt the large megafauna of the plains. However, these creatures may evolve a new adaptation, never before seen in any megalapid clade. They may evolve jaws. However, these jaws will be very different to those of the Masian osteopods. Instead of being a two-part jaw, where the tentacles help to grab plant matter, the jaws of these creatures may evolve from tentacles themselves. To evolve their tentacles into jaws, they may broaden and press together to form a completely enclosed chamber near the front of the creature's body. Once this occurs, these creatures may become extremely successful predators, as their jaws will allow them to bite chunks out of anything they come across, even allowing them to swallow small prey whole. As their jaws evolve, their six-legged walking style may restrict their speed, and so their front pair of legs may lift off the ground, and may eventually become vestigial. This may make these creatures the first ever four-legged Cyspides on the planet. Seeing as these limbs no longer serve a purpose, they may shrink in size, to not get in the way of the creature's jaws and walking limbs. However, their vestigial legs may still serve a purpose to these creatures. These creatures typically hunt in prides of up to 15 adults, finding and hunting variopods and caudopods to kill and feed their young. However, these creatures may also have a social ladder, with only one dominant male, a few subordinate males, and the rest of the pride being females. This means that they will need some way of differentiating each other to not get their ranks mixed up. This is where their vestigial legs may come into play, evolving into structures used to signify rank within the pride. The dominant male will have the largest and thickest vestigial legs, signifying his status as the leader. The subordinate males will have smaller, but still thick vestigial legs to signify their difference from the females of the pride. The females will have thinner, longer vestigial legs to differentiate themselves from the males, to signify their status as breeders, and the babies will have little nubs for their vestigial legs, showing that they aren't matured yet. However, upon reaching maturity, their vestigial legs will grow into the type determined by their sex, after which they are expelled from the pride to prevent inbreeding. We will call these bizarre Leptosoma the Neomaxilla. They grow up to 6 meters long and live for up to 35 years. With the abundance of food in the plains, it is inevitable that some animals will try and steal it from another animal to gain a free meal without doing any work. Perhaps a clade of basal Cyspides evolves to steal food from the Prizonogy by mimicking the neomaxilla, evolving into the planet's first kleptoparasites. Kleptoparasitism is a phenomenon on Earth where an organism evolves to steal food and resources from other organisms to gain the benefits without having to expend any energy in obtaining them itself. But why would the Cyspides evolve to mimic the neomaxilla in the first place? You see, the neomaxilla are dangerous predators, known to kill anything that comes too close to them. This means that animals who are preyed upon by the neomaxilla will naturally fear them, running away to avoid the confrontation and being killed. So these Cyspides may take advantage of this fact, evolving to mimic an adolescent neomaxilla that has been exiled from its home, pried to prevent inbreeding. But how would they do this? They may evolve a similar body shape and coloration to the neomaxilla, evolving a brown skin color and raised front legs. However, instead of becoming vestigial, the legs of these Cyspides may evolve into a pair of arms, allowing them to grab the food they attempt to steal from other animals. This is called centaurism, where an animal evolves to raise a pair of limbs off the ground that they use to handle food, eventually losing the ability to walk on those limbs. The next adaptation these Cyspides may evolve is broadened tentacles with sharp teeth, evolving to mimic the jaws of the neomaxilla without actually having any jaws at all. The final adaptation these creatures may evolve is a simple cartilage skeleton to be able to support their bodies, giving the appearance of a true adolescent neomaxilla. The culmination of all of these traits leads to these Cyspides being nearly indistinguishable from the neomaxilla, allowing them to exploit their appearance to steal food from any smaller animals they find. However, this comes with a few drawbacks as well. One drawback is that these Cyspides are now similar to an adolescent neomaxilla. This means that any real kicked-out adolescent neomaxilla may try to mate with them or initiate a mating ritual, which often leads to the adolescent neomaxilla getting angry at them. Another drawback is that they are now easily mistaken for neomaxilla young as adolescents themselves, meaning that female neomaxilla will carry them around as they remind her of her own children. While this may initially be a good thing for these creatures, if they are recognized as a false neomaxilla, the males of the pride will violently kill them and eat them. We will call these false neomaxilla the Lazagrosa. They grow up to 1.5 meters long and live for up to 17 years. Up until now, the terravermis have been quietly reproducing and decomposing matter in the background, not really seeing any need to evolve. However, one thing may push these creatures to adapt to life above ground. The Altophilo plains are littered with the oothicas of the coccolophoforms and the eggs of the megalapids and other animals. These eggs and oothicas are packed with nutrients, which no other animal has taken advantage of yet. So perhaps a clade of terravermis begins to take advantage of this as of yet vacant niche, evolving into the planet's first Ovivores, an animal whose diet exclusively consists of eggs. However, one issue these creatures have is their lack of water retention. These creatures never evolved any form of skin, seeing as they evolved to stay underground for most of their lives. But perhaps they evolved thick, scaly skin to be able to retain water in their bodies, allowing them to become independent of the soil and take up a life exclusively above the soil. To get around, these creatures may evolve to slither their bodies through the grass, similarly to earth snakes. But to be able to crack open the eggs they feed on, their arms may evolve too large, sharp scales that they can use to break open the shells of eggs and get access to the delicious nutrients within. We will call these brutal egg eaters the Avgophidae. They grow up to 1 foot long and live for up to 11 years. From the tall Altophilo to the slithering Avgophidae, it is clear that the formation of the open plains on Apovlitos has led to some truly odd creatures. Special thanks to all the fan artists on Discord who submitted artwork for part 2 of this episode. You all made this episode look a lot better, and your contributions to the project have been invaluable. However, one major change is about to alter the course of life on Opono forever, one with consequences seen on a global scale. Throughout our journey on land, the continents of Proto, Defteros, and Meso have been joined together in the supercontinent of Matsi. In the next episode, we will see the biological upheaval that occurs when the supercontinent of Matsi finally splits into two. Thank you all so much for watching. Don't forget to subscribe, like, and share your thoughts and suggestions for future episodes. See you when Matsi finally splits.